Assalamualaikum warahmatullahi wabarakatuh. My name is Nadia Binti Azman. I am from Group 2. So today I'm going to present our project report. But first of all, I want to introduce you our group members. First, Muhammad Shazul Binti Aziz, nama matrix CE210003. Second, Nikfiza Binti Puan Baharudin, matrix CE210150. And third, Nadia Binti Azman, which is me, CE210162. So for my part, I'm going to present you the introduction for this mini project. So in an RLC circuit, the most fundamental elements of a resistor, inductor, and capacitor are connected across a voltage supply. All of these elements are linear and passive in nature. Passive components are ones that consume energy rather than producing it. Linear elements are those which have a linear relationship between voltage and current. There are number of ways of connecting these elements across voltage supply, but the most common method is to connect these elements either in series or in parallel. The RLC circuit exhibits the property of resonance in same way as LC circuit exhibits, but in this circuit the oscillation dies out quickly as compared to LC circuit due to presence of resistor in the circuit. For this experiment, we are using another in the circuit. So for this experiment, we are using the oscillation dies out quickly as compared to LC circuit due to presence of resistor in the circuit. So for this experiment, we are using nodal analysis and mesh analysis for questions too. So nodal analysis is a method that provides a general procedure for analyzing circuit using node voltage as the circuit variables. Nodal analysis is also called the node voltage method. Some features of nodal analysis are as nodal analysis is based on the application of the Kirchhoff current law, which is KCL. And therefore, mesh analysis is a method that is used to solve planar circuits for the current at any place in the electrical circuit. Planar circuits are circuits that can be drawn on a plane surface with no wires crossing each other. A more general technique called loop analysis, with the corresponding network variables called loop currents, can be applied to any circuit, planar or not. Mesh analysis and loop analysis both make use of Kirchhoff voltage law, which is KVL, to arrive at a set of equations guaranteed to be solvable if the circuit has a solution. Mesh analysis is usually easier to use when the circuit is planar compared to loop analysis.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Nikfiza binti Baharudin. So I will present to you for the question. Okay, so for A is design your circuit to obtain an overdamped, critically damped and underdamped response. For the design, choose underdamped frequency omega in the range 200 till 1000 radius. So for the different value for each group is, so for our group we use 400 omega. Okay, so for IL is equal to 20 MA, BC equal to 10 volt, and IS equal to 5 ampere. Okay, so for damping factor, we use equation which is infinity equal to 1 over 2 RC. Okay, so for overdamped system, 1 over 2 RC equal to 1 over square root LC. Okay, so given omega range 200 to 1000 radius. Okay, so for omega is 400 radius second. Okay, so for the formula is we use 1 over square root LC. Okay, so 1 over 400, and so for the final answer for overdamped system is we got R equal to 1 ohm, L equal to 5.2 mH, and C equal to 1200 microfarad. Okay, next is critical damp. So for the critical damp, omega is used for which is 600 radius. Okay, so for the final answer for critical damp is R equal to 1 ohm, L equal to 3.33 mH and C equal to 833.33 microfarad. Okay, so for the last one, which is under damped system, omega is equal to 800 radians per second. So for the final answer is R equal to 1 ohm also, and L equal to 2.23 mH and C equal to 700 microfarad. Okay, so for B is find the expression of VCT and ILT for T0 as for each of your circuit designed in Q part A. Okay, so for the over them is omega equal to 400 radius, R equal to 1 ohm, L equal to 5.2 mH and C equal to 1200. Okay, so this is, so we use Laplace transform, which is R equal to 20 milliampere, V equal to 10 volt. So KCL is 5 over S equal to V over R plus Vs minus by Vs per second divided by 1 per second plus Vs minus by negative L2 over SC. Okay, so for the final answer is we got 4.98 over 5 plus 10 C 1 over 1 divided by 1 plus SC plus 1 over SC equal to Vs. Okay, so for the over them we got equal to negative 1.03 E square, power of negative 532.2 T minus by 3.15 E power of negative 30.125 T ampere. Okay, so for C is simulate the circuit. So we will simulate the circuit using multisim, use our value that we got in question A. So this is the under damped, over damped and critical damped. So this is our graph for IL and this is our graph for VC. So for the last question, which is D, analyze the response from part C that will give the shortest time. On reaching 80% of the final value, VCT give, comment and conclusion. Okay, so for the formula, we use final minus by initial multiplied by 80%. So for under them, we got 4.45, 9.418 micro minus 0 multiplied by 80%, so the answer is 367.534 micro s. So for the critical dam is for the graph we got 535.988 micro minus by 0 multiplied by 80%, and we got the answer is 428.790 micro US. So for the last one is over there, which is 612.557 micro minus 0 multiplied by 80%, so the final answer is 590.4 0.046 US. So this is the graph, this for the second graph and this one for the last graph. Okay, so for the conclusion is okay, so for the conclusion in this assignment, we built 3 parallel RLC circuits, which is under damped, over damped, and critical damped. For the resistor value is all same, which is R equal to 1 ohm. So next is we will calculate the ampere and also the omega to determine the response of circuit. So circuit 1 is an under damped system, and circuit 2 is over damped system, and circuit 3 is critical damped system. After that, we need to obtain the expression of VCT and ILT. So we know that the capacitor voltage inductor will always continuous. So the capacitor, inductor and also the resistor are parallel. So the voltage will be the same. Then we use infinity equal to 1 over 2 RC for damping factor. First, we obtain the overdamp value, which is L equal to 5.2 mH, C equal to 1200 microfarad. So for critical damp, L equal to 3.33 mH, C equal to 833.33 microfarad. So the lastly is under them, which is L equal to 2.23 mH and C equal to 7 microfarad. Okay, so for the critical damp, we will use the shortest time on reaching 80% of the final value of VCT, which is 367.354 US. Second is critical, then we'll use 428.790 US, and the longest time used to reaching 80% of the final value VCT is over there, which is time used is 490.406. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazul binti Aziz and my matric number is CE21003. So for today, I would like to present about our mini projects for electric circuit 2. So this is the circuit that I have do in the online simulation. And then this is the output when I calibrate it. So this is the grapher for PR1. So here you can see this the value for PR1. For PR, this is for PR4. This is the value when I run the circuit or simulate. Then this for PR3, the value of PR3. And this value for PR2, the value. And the last one, this is the circuit, and this is the grapher that I have run in this online simulation. So we go to the online simulation FI record, which you can see here. This is the online simulation when I click the button run here, and then we go through to the value. This is for value PR1. So we go to value PR4. This is the value, and PR3 for capacitor 2. This is the value that I have measured it, and this is value for PR2. So for the manual calculation, this what I have calculate using manual calculation. So I think that's all from me.
So I'm back again with the conclusion. I'm Nadia Azman. So in summary, we can understand the concept of second order circuit, RLC, and sinusoidal steady state analysis for this project. In addition, we can solve and perform circuit analysis technique for a given network problem using software simulation, which is multi-seed. As a result, we can implement our understanding of various circuit analysis technique. We can conclude that this technique can also solve the current or voltage response and solve steady-state expression using various circuit analysis techniques. With our understanding of skills, we can calculate and solve the questions given to obtain the value of overdamped, critically damped, and overdamped response for question 1. And then we can also improve skill in calculating and gain more knowledge in solving the problem. And then understand also the necessary steady state by calculating the steady state current and voltage expressions, and then we apply that technique in question 2 using nodal and mesh, as I mentioned before this in introduction. So this method is convenient. It allows us to reduce the number of equations that must be solved simultaneously. The nodal method uses Kirchhoff's current law to calculate nodal voltage, and the mesh method using KVL, which is Kirchhoff's voltage law, to evaluate currents. So the nodal method uses Kirchhoff's current law to consider nodal voltage, and the mesh method using KVL, which is Kirchhoff's voltage law, to evaluate mesh currents. So mesh is a loop which does not contain any other loops. So, and then we can gain our knowledge and skills using software simulation in multi-sims like build, design and construct. Also, we can simulate an analysis, a second order circuit, an AC circuit at the end of project session. So, by using that simulation, we can also use our basic skill to apply them in a work fields of electronic engineering and improve more. So, lastly, the outcomes of the project, we can compare the computation and simulation similarly according to our calculation and analysis. Besides, we can manage to prepare a technical report after the project was done, and we can gain knowledge about the task very well. So that's all from me. Thank you.